Hello everyone, this is Akila. Currently I am pursuing BTech first year in Vasarati Venkatathri Institute of Technology, bearing roll number 05D2. Today I want to explain an iterative method. Iterative method. What are iterative methods? To find solution to algebraic and translation equation, we have following methods available. They are bisection method, regular falsy method, iterative method, and Newton-Raphson method. Let us see what is the Newton-Raphson method. Let us take a function f of x equal to 0. By using intermediate value property, we can find the root lies between a and b if f of a is less than f of b numerically. Here we do not consider any signs before the f of a or f of b. Then initial approximation of root x not equal to a. If f of b is less than f of a numerically, then initial approximation of root x not equal to b. How to apply the Newton-Raphson method? To find the first approximation of root in Newton-Raphson method, x1 equal to x naught minus f of x naught by f dash of x naught. And the second approximation of root in Newton-Raphson method is x2 equal to x1 minus f of x1 by f dash of x1. We want to continue this process until we get two consecutive approximations equal up to 3 decimal points. What is the n plus 1th approximation of root in Newton-Raphson method is xn plus 1 equal to xn minus f of xn by f dash of xn. Let us see. In Newton-Raphson method, we have used the intermediate value property to find the root lies between. Let us know what is an intermediate value property. The statement for the intermediate value property is if f of x is continuous on closed interval of a comma b, and if f of a comma f of b have opposite signs, then at least one root of the equation f of x equal to 0 lies between f of a and f of b. Here, if we see the statement, that was unclear. We did not consider the signs of the f of a and f of b, which is numerically equal, which is numerically greater than the other, that is taken as the x naught. That means initial approximation. Let us take an example to know in depth about intermediate value property. Let f of x equal to x power 4 plus x cube minus 7x square minus x plus 5. Let us find what are a and b values for these f of x by using intermediate value property. Start from the 0. F of 0 equal to, if we substitute 0 in the place of x, we will get f of 0 equal to 5, which is a positive value. Let us take f of 1. F of 1, if we substitute the 1 in the place of x, we will get f of 1 equal to 1, which is also a positive value. Here we do not take 0 and 1 as a and b because they do not have the opposite signs. Let us go for further. F of 2. If we substitute the 2 in the place of x, we will get f of 2 equal to minus 1, which is a negative value. Here we have got the f of 1 and f of 2 have opposite signs. So root lies between f of a, f of 1 and f of 2. Here always smaller value is taken as a and the larger value is taken as b. So root lies between 1 and 2. Let us know some extra formulas which is present in the Newton-Raphson method. These formulas are called Newton-Raphson iterative formulas. And the first one, these formulas are used to find out the reciprocal of a number and the square root of a number reciprocal of the square root of a number and the kth root of a number. Let us see how to find the reciprocal of a number. To find the reciprocal of a number, the n plus 1th approximation of root is xn plus 1 equal to xn into 2 minus nxn, where n equal to 0, 1, 2, and so on. Square root of the number. The n plus 1th approximation of the square root of the number is half into xn plus n by xn, where small n equal to 0, 1, 2, and so on. To find the reciprocal of the square root of the number, the n plus 1th approximation of root is half into xn plus 1 divided by nxn, where n equal to 0, 1, 2, and so on. Kth root of the number. It is as similar as the square root. In place of 2, we are keeping k. Let us see what formula will be the output. The n plus 1th root of kth root of n in Newton-Raphson iterative formula is 1 by k into k minus 1 into xn plus n by xn power k minus 1, where n equal to 0, 1, 2, and so on. Let us see an example on Newton-Raphson method. Here, if you observe the problem, find real root of equation x power 4 plus x cube minus 7x square minus x plus 5 equal to 0 by using Newton-Raphson method near x naught. Near x naught, that means they have given already initial value. Here, we do not want to use the intermediate value property because we use intermediate value property to find the initial approximation. That means x naught. Here they have already mentioned the initial value. So we need not use the intermediate value property. Let us solve the problem. Given f of x equal to x power 4 plus x cube minus 7x square minus x plus 5. Here already they have mentioned what is initial value, x naught equal to 2. In Newton-Raphson method, we also need f dash of x. Let us find the f dash of x. F dash of x, which is equal to 4. Derivative of x power 4 is 4x cube plus derivative of x cube is 3x square minus derivative of 7x square is minus 14x. Derivative of minus x is minus 1. Derivative of plus 5 is 0. As the derivative of constant is 0, here the derivative of plus 5 is 0. Let us solve the problem by using Newton-Raphson method. By using Newton-Raphson method, first approximation of root x1 equal to x naught minus f of x naught by f dash of x naught. If we substitute x naught in the formula, we will get 2 plus 1, 2 plus f of x naught, which is equal to minus 1, and f dash of x naught, which is equal to 15. That means f of x naught by f dash of x naught, which is equal to minus 1 by 15. If we substitute in the first approximation of the root, we will get the first approximation as 2.06667. Let us find second approximation of the root. x2 equal to x1 minus f of x1 by f dash of x1. Here we have, in previous approximation, we have got the value of x1 as 2.06667. If we substitute the x1 value in the f of x, we will get f of x as 0.10497. As well as if we substitute the x1 value in f dash of x, we will get f dash of x1 as 18.18801. If we solve this, we will get the second approximation as 2.06090. Here, if we observe first and second approximations, we have not got the similar values. That means up to 3 places are not coincident. So we have to go for the further approximations. Third approximation of the root. x3 equal to x2 minus f of x2 by f dash of x3. F dash of x2. If we substitute the x2 value 2.06090 minus f of x2 0.00085, f dash of x2 17.90244. If we solve this, we will get the third approximation as 2.6085. Here, if we observe second and third approximations, 3 decimal places are coinciding. As we try to coincide 5 places, we have to go for the fourth approximation. Let us see what is the output of the fourth approximation. Fourth approximation of the root x4 equal to x3 minus f of x3 by f dash of x3. If we substitute the x3 values in the fourth approximation, we will get the fourth approximation as 2.06085. Here, if we observe the third and fourth approximations, both are coinciding up to 5 decimal places. So root corrected up to 5 decimal places is 2.6085. Thank you.